So this last demonstration will cover trunking and pruning. So we're going to be taking a look into having a connection between two routers switch. So what we have here, we do have two Cisco switch. I'm going to explain later what will be the native VLAN for. It is really important to know what's the native VLAN because typically you won't have other vendors compared to having two same vendor. In this case, we have one vendor, which is Cisco. However, that's not the reality all the time, where you would typically have a non-Cisco switch that you'll be connecting, and this is where the native VLAN will take in place. Okay, so let's talk about dynamic trunking protocol, or DTP. So this dynamic trunking protocol is available on the switch that we have here for 2960. So first off, we'll configure the switch with a dynamic desirable mode. Let's go to the PC here. I'll use the terminal window instead. Yeah, so this one right here is, let's go to enable, passwords class, type in conf t. Let's go to the interface 01. And let's give the command of switch port mode dynamic desirable. So this is the second command that we have. We're going to be taking a look in trunk and auto as well. Okay, so as you can see, those different ports actually have changed into status up, down, and eventually VLAN has been changed to down since we're not using it, and also went back to up. Automatically connects that FA01 to VLAN 1 in this scenario. Okay, so next command that we wanted to do here is let's show interfaces trunk. So take note of this command. You'll be using this quite a bit for troubleshooting. And this command will show you port numbers, what will be the mode in this F01. It shows desirables because we manually configure this specific port. Native VLAN is at 1. By default, your native VLAN will be assigned to 1. The same with your default VLAN of 1 when you plug in any interface to your ports. This also shows that port FA01 it allows 1 to 1005. So you'll be able to have all of those VLANs that will be able to use this F01 itself. All right, let's go to the other switch. So I'll go directly to the switch here on the command line interface. And without changing any configuration on it, type in enable password class. Let's show interfaces trunk, and let's compare this to S1. And on this switch, it actually shows that FA01 is configured as auto. So when you purchase a Cisco switch, it automatically defaults to auto as a mode, and it would it depends on the configuration of the other switch where it would change to an access mode or a trunk. So those are the two important modes that we have on here, and we'll talk about that in detail in our other class. Okay, so next thing that we want to do here is to manually configure the trunk and set native VLAN 1000 on both devices. So we'll start off with the switch 2 here since we're on this device already. So conf t to interface FA0/1. Let's assign this to a trunk. I'm really having trouble typing the word switch. Switch port mode trunk. Yep, and do switch port again. Trunk, and we'll assign a native VLAN 1000. Yeah, so this is similar to assigning an access to a VLAN, right? However, we're using native VLAN instead of the word VLAN, and again the ID or the number. Yeah, so we have assigned this to switch number 2. We'll do the same thing on switch 1. Interface F01. We already have this. Oh, actually, we have this earlier as a desirable trunk. So let's move this to switch port trunk and give direct switch port mode trunk. Okay, I think I wanted to stop here to show this error message, or an update actually. This is saying that the native VLAN mismatch, where on S1 we haven't moved the VLAN or native VLAN to 1000 yet. So this is saying that you have a mismatch here. Something is not right. So after we give the command of the switch port trunk native VLAN 1000, this will actually tell you that it was successfully fixed. The CDP here is what we call a Cisco dynamic protocol, where it will communicate to other Cisco devices within your network, and it will provide you with an update, something like this. So the error message here is saying native VLAN is not matching up, right? That's why it's a mismatch, and it will keep on coming back until you fix the problem. Okay, so let's try to fix this problem. Switch port mode trunk, switch port trunk native VLAN 1000. Right, so you can see there earlier it actually prompted with a second notification that there's still a mismatch, and let's give it a few seconds here and see if this will still show up for us. Okay, so it's not giving us any notifications anymore. I was actually hoping that it will give us like a successful, or this mismatch has been fixed. However, it did not do that. I would expect that on your physical device, not on a packet tracer, it would actually give you the prompt to give you a successful fix for your VLAN. However, yeah, you can see it here on the packet tracer. Alright, so let's type end here, and let's check the interfaces again. Show interface trunk, and let's check the mode. The mode here is show as on, since both of the switches that we have, S1 and S2, has been manually configured to trunk mode. Right, and native VLAN here is showing us 1000. So we've moved it from 1 to 1000. Let's also check the other side. Show interfaces trunk. And we'll be expecting the same result, where you have a mode of on, it is trunking, and the native VLAN is 1000. So going back to the concept of native VLAN, if you have a different or non-Cisco device within your network, it will look for the VLAN, the native VLAN, and it will send the 802.1.q encapsulation going to that VLAN. So it will use the 1000 VLAN ID. Alright, so let's do a little bit of troubleshooting here. It's what we call pruning. So before we actually prune from PCA to PCB, let's try to give this a continuous or simultaneous ping. So type in ping 192.168.99.11. Oops, sorry, forgot the dash T. So we'll give you a continuous ping. So ping dash T 192.168.9.11. So I want to verify that's the IP address that we have on the second PC. PCB, same IP address. Alright, so you can see here, this will give us more than 4 pings. It will be continuous. Alright, so next step that we wanted to do here is to change your S1 configuration and remove the trunk to allow specific VLANs to run within this F01 and F01 connection between the switches. Let's go into the switch. Since this PCA is running a command prompt, I'll go directly to the switch command line interface or the CLI to make the change. Conf, I'll go to interface FA01. FA01 is the trunk that we have between your S1 and S2. Let's give it switch port, trunk, allowed. Let's do VLAN 10, 20, 100. 1000. Because we have 1000 in there. Okay. So after typing that command, go back to our ping here, and it's showing ping timeout. This is expected because the switch that we have, we missed the 99. The 99 is the port that's using or being used between these two switches. Keep in mind that they are using 192.168.99.2. Forgot to change this other side of the switch. Let me just check that. Oh, edit. So it is 192.168.99.3. So this trunk need to know that you need to allow VLAN 99 to pass through the trunk in order to your clients or the PC to communicate to one another. So to fix that, okay, so to fix this, we just need to allow the F01 here and recognize that VLAN 99 should be included. I actually omitted the 99, intentionally omitted that, just to show you that it will not ping, or PCA and B will not communicate with one another without allowing the VLAN 99 between in our trunk. Okay, so we have an error. Okay, I think the space that I have, so 10, 20, 99, and 1000. Let's go back on the PC here, and as you can see, oh, still timing out. This might take a minute, so we'll wait for that to change to a successful reply. Excuse me. Okay, while we're waiting for this, I'm gonna go back to our switch here and do show interfaces. I'm using the do command. Interfaces trunk. Just wanted to double check that, yeah, this is actually showing the 99. There we go. So we're actually seeing the successful reply from PCB to PCA, since we actually allowed the trunk or VLAN 99 to pass through the trunk here. The concept of trunking is mainly allowing multiple VLANs to pass through one port. In this example, F01 on S1 and F01 on S2 are considered a single port from each switch, and you'll be able to use that to have multiple VLANs pass through that connection or trunk. Okay, so before I actually end this video, I know it's getting lengthy. I wanted to talk briefly on VLAN dot dot. So VLAN dot dot is the configuration file that all your VLAN information are stored. In comparison to your switch, which all the configuration are stored in a running config, or if you do show run, it will show the running config. For VLAN, we use the VLAN dot dot to store all the configuration file that we have here. So let's type in show flash colon, and this will show you all the information that we have here. So the bin is the binary file, and this is the VLAN dot dot. So this is where your file is stored. All the VLAN except, sorry, let me rephrase that. All the VLAN except VLAN 1. Right, so to delete this, you have done this quite a bit from the previous semester. VLAN dot dot, press enter. What file do you need to delete? So since those are matching, you can just press enter, and to confirm that this belongs to the flash memory, press enter, and that will automatically be deleted for us. One last thing before we end the video, I wanted to show you the port numbers that this specific VLAN is actually working, specifically the VLAN 99. So let's go to PCB. And what we wanted to check here is the the MAC address. So let's type ipconfig /all. So the MAC address of PCB, where is our PCB? Okay, so we'll just keep this the last 4 alphanumeric digits, so CA49. So keep that in mind. So that's your F0A. Get Bluetooth in the fast Ethernet 0. So CA49. Yeah, so from PCB, let's try to ping PCA. Yeah, so we're getting some replies here. Okay, let's check the switch number 2, and let's give this the show MAC address -table command. So the CAF09, so that's the last digits of the MAC address that we have from PCB. It actually shows here that it passes through F018, which is the port that is connected or to the switch, and the outgoing port is going to F01. Right, so let's check that on the other side of the switch, if that's actually the number that is going out. So show config, show MAC address table. Okay, so F09 here, so you can see it is used. It uses F01 to basically let the VLAN 99 pass through between that port. So this means that this connection between your switch uses VLAN 99 when it tries to communicate from PCB to PCA. Okay, so that will be the end of this video. I know it's quite a bit lengthy. Our next demonstration will be on Tuesday. I'll be talking about inter-VLAN. So this is where you create a router on a stick that will let you communicate between your VLANs. So it's similar to trunking. However, we're using a specific router to basically create sub-interfaces and to let your VLANs communicate to one another.